Well, we're going to start on section 10.1 called the rectangular coordinate system. This is really a fun move in mathematics. It literally marks one of the biggest innovations in mathematics and has had profound effects. It was introduced in the 17th century, I believe, by mathematician and philosopher René Descartes, the same one who says, "I think, therefore I am." The Cartesian plane, after Descartes, the last name, is also the name of what we're going to call the rectangular coordinate system. And this is a big change. We're literally moving from one dimension to two dimensions. So I don't know, I can't see myself, but if you can imagine just looking at the edge of this, it's Notepad, and that's your number line, and we're literally moving from the number line all the way to a flat plane. So that's what's going on. It has allowed so much mathematical progress, and mathematicians would be quite lost without the rectangular coordinate system. So we're going to introduce some key vocabulary in time, and let's just introduce. The first thing you're going to notice when I bring up my writing pad is we have a brand new background. That background is because we're going to be wanting to plot things, and we will need to have something like this graph right here. So the first vocabulary item we're going to talk about, so let me just introduce you to the rectangular coordinate system. It's literally, you're seeing just a small portion of it right here. This is it. So notice we have two really solid lines. This line right here and this line up here. This line here, and I may have to do something. Let's try that. This right here is called the x-axis. And the x-axis literally corresponds to this horizontal line that's our regular old number line. And remember, we would always split our number line right in two, and that would be the 0 point. When I add another line perpendicular to it, and I can't even draw it good when I have lines to trace, this is the x-axis, and this is the y-axis. And you can see that over here is demonstrated by the x-axis and the y-axis. I'm going to need some room to write here, so I got to be careful. And I literally can, as I discovered a while back, erase this, so that's imported as a probably a bitmap image. So what's the whole point about this is, in the one dimension we just had numbers like 3 or 7 or 1/2, and they were located along the number line. So we'll say 1/2 is here, 3 is up here, and then of course I'd extend the line more and I would find 7. And they're just literally points on a number line. So we're going to still have that. It's going to be called the x-axis. And the x-axis denotes the distance from 0. Over here, notice we have the x-axis and the y-axis. Right here in the very center is going to be a very special point. So over here, drawing it over here, This point right here is called the origin. And the point that I just kind of made big right here is the origin on this nice graph. So let's look at what's called an ordered pair. An ordered pair is a pair of numbers. And those numbers are enclosed in parentheses. And the first number is going to be a number along the x-axis. And the second number is going to correspond to a number along the y-axis. Think of ordered pairs as directions. So if you've ever lived, imagine people living in a really nicely laid out town where all of the streets run precisely east and west and north and south. The east and west ones are called avenues, and the north and south one are called streets. So you would find an address by a certain street and avenue. That's kind of like what's going on here, except our new objects in this world are no longer numbers, but points. And I'm going to highlight some points over here. Right now, of course, a point could be anywhere. Even right there, literally anywhere. But these are points. Now, of course, a point has an address. And that address is given as an ordered pair. In the form where the x direction is given first and the y direction is given second. So let's look here at this first point. So it has an address. So this is, let's give the special address. This big point I write here is called the origin. It's kind of like our starting point. And the origin has an address of 0, 0. So remember, this is an ordered pair. The x value is 0 and the y value is 0. So let's find, so the origin has this as its ordered, as its address. That looks like a face, but it's supposed to be 0, 0. This point right here, well, if I move in the x direction along the number line, I go one place to the right, and I go straight up. That tells me that the x direction, or the x value of this point, is 1. Now, if I start at that point and move perpendicular to the y-axis, and I count the distance I am from the origin, that's also 1 up. So the point being here is this particular point corresponds or has as an address 1, 1. Well, let's see if we can find so these addresses, what I'm calling an address, are called ordered pairs. In the rectangular coordinate system. So let's see if we can find the ordered pair coordinate. That's what we use for addresses. Coordinate of this particular point? Well, let's start down here at the x-axis. I'm moving 1, 2, 3, 4, 5. And if I go so, the first x-coordinate will be 5. Now I'm going to move over here until I hit the y-coordinate, right there, the y-axis rather. And then how far am I from the origin? Well, there's 1, 2, 3, 4, 5. So the coordinate, which corresponds to an ordered pair, of this particular point is 5, 5. Well, what about this one down here? Well, again, it's going to have some coordinate in the form of an ordered pair that tells me where it's located. So again, I move over, starting at the origin, 1, 2, and go down, and I hit it. So the first address is 2. And here I'm going down. So that's in the negative direction. So on the number line, when we divide the number line at 0, this side is positive, and this side down here is negative. When we look at the y-axis, this is the y-axis that corresponds to this dark line right here. We also divide it right there at the middle at 0. And numbers up here at the top are positive, and numbers down here are negative. So here I found that the address, the x value of this point is 2. So I need to find the y value. I need both. So this is -1, -2, -3, -4, -5, -6, -7, -8. So that corresponds to the coordinate 2, -8. And I want you to try right now, pause the video if you need to, and try to find the coordinate, that's supposed to be a comma there, of this point right here. Okay, so let's see its x value. So here is my 0, 0. So this corresponds to -1, -2, -3, -4, and -5. And the y value, starting up here, how far are we from the origin? Well, there's 1, 2, 3, 4, 5, 6, 7, 8. So the coordinate of this point is -5 and 8. So notice what we have here. We have a graphical representation of points in a coordinate system where there's an awful lot. And I distinguish it, this is the two-dimensionality of it, by a value that corresponds to its distance out from the x-axis, the origin of the x-axis, and to the distance out from the 0 on the y-axis. So this is a point. That's its graphical representation. That's what it looks like. But this, on the other hand, is its mathematical or symbolic representation. So what did we just do? We just connected mathematics with visuals. So data, look at some more stuff right here. Let me clear off some area. I just want to make sure I hit all of the vocabulary for this particular point. Although some of the vocabulary I won't use. And this next one, I mean, sometimes perhaps. But part of the vocabulary is called paired data. So some of you are following the COVID-19 spread, and we can actually have a table of data. And the first table might have in it days or dates, and the second value might be the number of cases. So on day 20 in Florida, say we had in Brevard County, 2 cases. On day 23, we had 4 cases. On day 26, we had 8 cases. On day 29, we had 16 cases. So this is paired data. If I actually consider the dates to be my x-coordinate and my number of cases, my y-coordinate, these correspond to points on a graph with the following coordinate values. And I could plot the data and observe as the dates increase by every 3 days, the number of cases double. This is a type of growth that's really, really fast, and it's called exponential growth. But you won't get exponential growth until you get into college algebra, if you take college algebra. The point being, it's really, really helpful to have paired data where there's 2 bits of data, and using this system we can literally plot the data and look at patterns. So this, the insight is math becomes visual. And indeed it is one of the greatest advances in mathematics. And unfortunately I don't think René Descartes gets enough credit for it. He was both a philosopher and a mathematician, and sometimes I think they didn't like his philosophy, so they ignored his mathematics. So here's what we're going to do. We're going to plot the following ordered pairs, and we're going to plot them here, but not on this. So what I'm going to do is, I'm experimenting with this, is I'm going to move to an entirely new section, and I'm going to make things bigger. And I'm going to try my best to draw a graph. So this is going to be my x-axis. And I'll make this my y-axis. Going up and down is harder for me. And of course, I'm not tracing on the screen. If you're curious, I have this little pad right here. And this is a special type of pen, and that's what allows me. I basically I write on this and look at the screen to see where I'm at. So if you were curious, now you know. So this is my x-axis. I'm going to make it a little bit bigger than that. This is my x, and this is my y. So this right here is my origin. So let's get another color. I think maybe red might work for our points. So this point right here is the origin and corresponds to the address or the coordinate 0, 0. So we are asked, we are given -2 and 5 as a coordinate. So this is the mathematical expression. So we're asked to find its visual location. So remember, every ordered pair, coordinates comes in ordered pair, we have my x value first and my y value second. So this says start at the origin and go to the left 2. -1, -2 puts me right here. Then go up 5. That's 1, 2, 3, 4, 5. So right here I have the visual representation of -2 and 5. So let's do now 0 and -4. So that says start at the 0 point on the x-axis, and that's right there, and then go down go down 4, or go to -4 on the y-axis. So that's -1, -2, -3, -4. So the point that I want to get actually lies on the y-axis. And right there is the point, -0, -4. So it's this point. These were just me, these little lines right there were me just counting off. This is the point it corresponds to. Now let's do 2 and 2/3 and 4 and 1/2. So here you just kind of have to eyeball it. And that's all we're going to do. 2 and 2/3 is almost 3. And 4 and 1/2 is exactly between 4 and 5. So again, 2 and 2/3 is my x value. So here's 1, here's 2. Now I'm going to say about right here is going to be 2 and 2/3. And then I'm going to go up 4 1/2. So there's 1, 2, 3, 4 1/2 right there. So this point is 2 and 2/3, 4 and 1/2. And the final one we're asked to do is -1 and 4. So again, remember, if you always get lost, these are always in the form of where it's located on the x-axis and where it's located on the y-axis. So I'm going to start with my 0 and go to -1 on my x-axis, which is right there. And then I'm going to go up 4. So that's 1, 2, 3, 4. So this is at the address -1 and 4. So as it turns out, I'm going to kind of use this one, that many times we want to refer to different, you can imagine this kind of divides the entire plane, the plane is the entire flat space, into 4 different parts. This first part is called quadrant 1. These are quadrants. Quadrants meaning fourths. And it consists of all values of x greater than 0 and y greater than 0. So any point in here in this quadrant, they use Roman numerals, I don't know why, it has a location x and y. And whatever that x is, it's going to be greater than 0. And whatever that y is, it's going to be greater than 0. So we're going counterclockwise. And over here is quadrant 2. and any value xy, or any point in this quadrant, has x less than 0, but y greater than 0. For example, minus 1 and 4. Just an example, that's not exactly where it's located. Over here is an example, 103. Now, of course, I'm just writing them down, not actually showing you where they would be located. So the next quadrant is the third quadrant. And any points here, xy, will have x less than 0 and y less than 0. For example, minus 3, minus 10. And our final quadrant is the fourth quadrant. And here, our x values are going to be greater than 0, but my y values are going to be less than 0. Points that lie on the boundaries, for example, this point right here, are neither in quadrant 1 or in quadrant 4. This point is said to lie on the x-axis. Similarly, a point right here that straddles, is on the boundary between quadrant 1 and quadrant 2, lies on the y-axis. All of that together with the special point right here, 0, 0, which is the origin, is pretty much all you need to know to familiarize yourself with the coordinate plane. So let's see what else we're supposed to do and see how well we can do it. So how are we going to connect this with algebra? Well, we have equations, and we've been looking at equations. I'm going to change the color here to be more consistent with what I have. You've been dealing with equations like x plus 20 is equal to 3 times x minus 5. That's an equation, because you see the equal sign there clearly. This is called an equation. In the variable x, because our only variable is indeed the variable x. However, sometimes we can have equations in two variables. For example, x plus give me a second. Merge visible layers. Plus, still not working. Technology is great when it works. When it doesn't, right? Okay, that will work. I just got to make it a little bit bigger. Plus 2y is equal to 6. This type of equation right here is called an equation in the variables x and y. So as it turns out, just like any equation, if I am given a certain value of x and another value of y, those values may make this equation true or false. So let's check and see. So I have the equation x plus 2y is equal to 6. So let's check if x is equal to 1 and y is equal to minus 2. We'll make this a true equation. Well, as always, I replace x with its value. Then I replace y with its value. So that's 2 times minus 2. And we want to know, is that equal to 6? If it is, then we have what's called a solution to the equation. But indeed, it's not a solution, is it? Because this is 1 minus 4, and 1 minus 4 is equal to minus 3. And minus 3 is not equal to 6. So x equals 1 and y equals minus 2 is not a solution. And can you anticipate what we're going to be doing? I've already got a way to group together x and y. They're called ordered pairs. And indeed, if x is equal to 1 and y is equal to minus 2, then I say this ordered pair is not a solution to, and I'm going to label this equation equation 1, equation 1. So that's pretty much what we're doing. We're actually looking to discover ordered pair solutions. For example, let's try again, we'll stay with what I've got here. X plus 2y is equal to 6. Let's try another value of x and y. Don't need that. Don't need that. We can just get rid of it. Somehow this is oddly satisfying. Anyway. Decrease, decrease, decrease. Go back to my marker. So let's find and try this solution. 0 and 3. Remember, this is an ordered pair. And I want to know is, the question is this ordered pair a solution to equation 1? That's what I want to know. And this is equation 1. So what I do is, remember, my ordered pair always comes in values x, y. So this says x is equal to 0, but y is equal to 3. And indeed, 0 plus 2 times 3 is equal to 6. So yes, the ordered pair 0, 3 is a solution to the equation. Is it the only solution? Well, let's see. Let's check and see if the ordered pair 6, 0 is a solution to equation 1. So I replace, remember this is x, x is 6, y is 0. So 6 plus 2 times 0 is equal to 6 plus 0, which is equal to 6. So the ordered pair 6, 0 is also an ordered pair solution to equation 1. As it turns out, if I make a set of all of the pairs, ordered pairs x, y, such that x plus 2y is equal to 6, and I plot or I graph all of those ordered pairs, I'm literally going to get a line. I'm going to get a line. And the line would look something like, if this is the point 0, 6, it would look something like that. So yeah, we're going to be plotting a lot of lines. So let me go ahead and get us some more working space. And now you can kind of see what's going on. And it's kind of fun because we're literally in 2 dimensions now. So here we have the same equation. So this is problem 1a. So our equation is x plus 2y is equal to 6. And what they're doing here is they're giving us 1/2 of an ordered pair. Now they're representing it as 2, comma, blank. But we know that blank here is a y value. So what we have to do is, if x is equal to 2, can we find the y value such that 2 comma this y value is a solution to this equation? Well, let's do it. Well, x is equal to 2. My y value is my unknown. So we're going to solve for y. So I'm going to move the 2 to the other side. So that gives me 2y is equal to 6 minus 2. In other words, 2y is equal to 4. So if I divide both sides by 2, I get y is equal to 2. So it turns out that the ordered pair 2, comma 2 is a solution to this equation. Now, the second thing that they've done is they said, okay, we found one ordered pair solution. I gave you x, you find y. So now let's see if they can do it the other way. The next thing they do is they give us not for sure what's going on or what's causing this, but whenever I do that, it's probably because I have that bitmap there. They give us a y value of 3 right here. No, it's minus 3. And they want us to find the corresponding x value such that that resulting ordered pair is a solution to this equation. So let's do it. X is my unknown. Y is given to me to be minus 3. So this says x, 2 times minus 3 is minus 6, is equal to 6. Well, I'm almost there. All I need to do is move this 6 to the other side. When I do so, the minus 6 becomes plus 6. So I get x is equal to 6 plus 6 is 12. So I found another ordered pair solution to equation 1, and it's 12 minus 3. You might be curious and asking yourself, how many ordered pair solutions are there? Literally, there is an infinite number of them. So let's go ahead and continue on down this path. Except now we've been given another equation. This is b. So now my equation is y is equal to 1/3 x minus 2. And they say, okay, I'm going to give you a 6. You find the corresponding value of y that makes this equation true. They're just leaving it a blank, but I'm writing in the y there because literally what we're going to be doing is given x is equal to 6, we have to solve for y. So let's do it. Y is equal to 1/3 x is equal to 6 minus 2. But that's equal to 6 divided by 3 is 2. And then I subtract 2 from it. So that tells me y is equal to 0. So I found the pair 6, 0 is an ordered pair solution to equation b. So the next thing they do is they say, okay, now I'm going to give you the y value. See if you can find the x value that makes this a true equation. In other words, that would make this an ordered pair solution to this equation in two variables. It's an equation in x and y. So again, we'll start all over. So our y value is minus 1/3 is equal to 1/3 x minus 2. So how do we solve for these problems? We multiply both sides of our equation by the LCD of our denominators, but our denominators are the same, so we're going to multiply each side of this equation by 3. The entirety, you have to be really careful and make sure you multiply everything on the right hand side by 3. The result is I'm going to clear some fractions. So 3 times minus 1/3 is the same as 3. If you want, let's just get used to doing this. You have a 3 here and a 3 here, so that cancels and I get a minus 1. This cancels here, so I'm having an x, but I'm multiplying the 3 also over to there. So 3 times 1/3 x, the 3's only cancel for that multiplication. But then I have to go back and grab the 3 again and multiply it by minus 2. I get minus 6. So if you don't like that explanation, here's another one. 3 times minus 1/3 is the same as 3 divided by 3, which is 1, times minus 1. And I get minus 1. So now using distribution, 3 times 1/3 x is the same as 3 divided by 3 times 1 times x, and that gives me my x. Then I have to distribute it to the second, so that gives me 3 to the second term. So 3 times minus 2 is 6. At any rate, that's where we get. And now let's solve it. I'm solving for x. So I'm going to move the minus 6 over, and it becomes plus 6. So minus 1 plus 6 is 5, is equal to x. So I just discovered 5 and minus 1/3 is another ordered pair solution to b. Good. Yeah, we've got several more of these to do. It's a very good exercise. So I'm going to give myself some more room. So at this point, you should be trying to do one of these on your own. So this is 3c. And we have y is equal to minus 2x. So here they've given us the value of x is equal to 0. So we want to find the value of y that makes this an ordered pair solution. So y is equal to minus 2, x is equal to 0. So y is equal to minus 2 times 0 is 0. So that gives the ordered pair solution of 0, 0. And remember, an ordered pair solution is a value x and a value y that when plugged into an equation in the variables x and y make it a true equation. Now the next thing they're doing is they're not going to give us the x, but they are going to give us the 6, which is my y value. And I'm going to use that information to find an ordered pair solution. So notice a pattern here. It doesn't seem to matter if they give me the x first and leave the y for me to find out, or if they give me the y and leave the x for me to find out. It doesn't seem to matter, and that's going to be true in general. So again, I'm solving for x. My y value is 6. So I'm solving for x. Now it's almost solved for me, right? So I divide both sides by minus 2. Minus 2. So that gives me minus 2 divided by minus 2 is positive 1. So that gives me x by itself on the right-hand side. And 6 divided by minus 2 is minus 3. So this gives me the ordered pair solution minus 3 and 6. Good. So let's get some more room and do 3D. And definitely you should pause after I write this down. You should pause and see if you can do it on your own. So this is 3D. And we're given the equation x minus 4 y is equal to 2. So again, notice these are equations in two variables. And the first thing they do is they say, okay, I'm going to give you a y value, and that y value is going to be minus 1/2. Can you find the x value for me so that this becomes an ordered pair solution to this equation in two variables? So pause the video and see what you get. Okay, I'm assuming you had time to pause it. I myself don't pause, I keep on going. So my y value given to me is minus 1/2. So now I just simplify. Minus 4 times minus 1/2 is the same thing as minus 4 divided by 2, which is minus 2 times minus 1, which is plus 2. And that is equal to 2. So now what I do is I move the 2 to the other side. So I have x is equal to 2 minus 2, which gives me x is equal to 0. So I discovered that 0 and minus 1/2 is an ordered pair solution to this equation in the variables x and y. So the next thing they do is they give us a value of x and see if we can come up with the value of y. The value of x they give, in this case, is -2. So say, well, I'm going to say x is -2. Can you find me the y that makes this an ordered pair solution? So my x is -2, and I'm going to solve for y. So again, I want to isolate my y on one side. So I'm going to move this term over here to the other side. So that's going to give me -4y is equal to 2, and the -2 becomes a +2. So that gives me -4y is equal to 4. And now I'm going to divide both sides by -4. So -4 divided by -4 is 1. So that gives me y is equal to 4 divided by -4 is -1. So we just discovered that the ordered pair 2 and -1 is an ordered pair solution to equation 3D. So the next thing that they want us to do is to plot excuse me, several ordered pairs. So I'll write the ordered pairs down here, and then we will plot them. But I have to draw, and I'm not happy with it, but I have to draw, maybe if I can get this ruler to help, I have to draw well, I'm trying, people. And maybe I can do this on my own. I'll clean it up here in just a second. Good enough. Let's erase this. Kind of trim some of this down. I wish I had artistic abilities, but I don't. But you can see what we're getting at here. Okay, so this is my y-axis, and this is my x-axis. And we're asked to plot the following ordered pair solutions, and I completely have lost. There we go. So we want to plot 2 and 3, -4 and 0, 0 and 1, 0 and 0, and 1/2 and -3. So not only are we going to plot them, we have to state where they lie, in which quadrant they lie, or if they lie on one of the axes. So let's plot 2, 3. So let's go over 1, 2, and up 3. 1, 2, 3. So right there is the point 2, 3. And this is in quadrant 1. Just a reminder, this is 1. This is 2. This is 3. And this is 4. So this is in quadrant 1. So now let's plot -4 and 0. So I start on the x-axis at the origin, and I go -1, -2, -3, -4, and the y value is 0, which is right there. So this is minus 4 and 0. And it lies on the x-axis. It's not on any coordinate. It straddles a coordinate. This is 0 and 1. So again, we start at the origin. And my x value stays at 0, but I go up 1 point. So it's this point right here, 0 and 1. And 0 and 1 lies on the y-axis. And we already know where the point 0, 0 is. This is 0, 0 right there. And it's the only point with its own unique name. It's called the origin. And then 1/2 and minus 3. So we're going to move over 1/2 and go down 1, 2, 3. About right there. This is 1/2 and 3. And it lies in quadrant 4. Okay, practice that and get used to it, because we're going to be in this coordinate system of 2 dimensions for an awful lot, and the remainder of your math, especially if you go to intermediate algebra, we do quite a bit in the rectangular coordinate system. So now, as a fun little introduction, we just moved from 1 dimension to 2 dimensions. And I think that's a really cool thing, because we can visualize mathematics.